Okay. We have 20 minutes. And in the first 10 minutes, I will make a short introduction to concept of multi-agent robotic systems. After that, we will try to make a demonstration where you will see how connected robotic arm, small gig toys robot dog, and smart lamp connected to home assistant local server will work together under Polkadot ecosystem or Kusama parachain control. So what we will talk about today? First of all, I will try to give you a short introduction to multi-agent concept in robotics fields, because in this year a picture of what is agent-based autonomous agents paradigm is a little bit different after artificial intelligence rise. But basically, the autonomous agent approach happens in robotics 20, 30 years ago. So, secondly, I will explain you our vision of how networks like a Polkadot can be adopted for physical object manipulation and why it can be interesting for startups, for everyone who interesting to make their smart devices hardware company. After it will be demonstration and 2-3 minutes about our experiments, what we are doing right now with my team. Multi-agent systems in robotics. If you will look in internet, different definition of what is a multi-agent systems, the first sentence will be, I guess, nothing for you. Because it's like a mirror. Multi-agent systems, it's an agent-based system, so it's not clear the picture. But if you will look on these three characteristics, you will find something. And what is funny for us from crypto industry is that some of the points or characteristics is very close to what you heard mostly about validators or decentralized networks. But it's how these characteristics was unveiled, and different researchers published scientific papers 20, 25 years ago about some interesting natural characteristics of complex robotic scenarios where we try to connect, for example, smart motion sensor with automatic door engines and make some more complex and useful service. What researchers found when you try to make it such difficult task? First of all, our multi-agent systems has a limitation of viewpoint of any agent. It means that nobody who involved in the complex scenario don't know everything about the system. They have their a limitation of viewpoint, what they catch from the whole system, and they know mostly about some specific part of the whole multi-agent system, what is important for this engine. Secondly, autonomy. Our agents involved in complex scenario mostly has their autonomy. It means if you take back motion sensor from the automatic door, it can be useful, for example, for your smart home security reasons. So you can just put your motion sensor in flat, and you will get push notification when you outcome of your home and your cat's moving in restroom or bathroom. And last one, and interesting, is the decentralization. Some of the guys said me almost time, if you will look on limitation of viewpoint and autonomy, that it means that it's a decentralized network or decentralized system. But it's not true. For example, some of the agents involved in multi-agent system can has their limitation of viewpoint. It's, I guess, some natural. They can has their own services, what can they provide autonomously. But you can imagine the system where some of the agent, which is not understand everywhere and everything inside, will has a root access to other sensors or manipulators inside system and can control. So some of the agents can has their autonomous, everyone has a limitation of viewpoint, but if you will not strongly restrict to our agents to push on another one or force some commands, that the system will have like a broken scheme. So let's look on this simple example, what I showed you, explained you before. For example, we have two engines, motion detector and automatic door controller. And each of them can work separately. But if you connect it together, it will be much more useful service for example, supermarket, where hundreds and thousands of people moving every time and they don't want just spend some time to open the doors. But in reality, it's not where you will find that the multi-agent systems for robotics mean something, because it's too much simple example. Much more interesting, what right now, for example, happening with the logistics, indoor warehousing. So maybe you saw a lot of videos about Amazon warehouse where thousands of small mobile robots moving at the same time. And now let's imagine you are head of research and development of the big company, and your next task is our company own 100 of new mobile robots. Please make a communication layer, try to make the system where all these mobile robots will work perfectly. They will have avoid collisions, avoiding obstacles. It will work with environmental around, open the door, cross the checks of the supply chain tracking, and so on. So the basic idea how most of the people engineers will start to resolve this issue is to create server in, for example, left top place of the warehouse. Create some source code to make traffic management system on the board. Each mobile robot will be connected to the server. The server will resolve our collisions on the routes of our small robots. If some of them will go into automatic door, it can send requests to the server. Server can communicate with the automatic door API, and door will be open. Yeah, it can be done in this program. But what, in my experience, more interesting? If you will succeed with your one warehouse in Kansas, for example, and your company will try to multiply this same scheme to the other places, what you will find? The first, I called it Luftdaten use case. It's an example of project originally from Stuttgart, where one small team tried to build pollution measurement sensors network for just Stuttgart. It was succeed and good use case, and hundreds and thousands different sensors from French, other cities of Germany, Poland, and other countries started to connect into the same server. Map of the pollution measurement map start to work not perfectly, and that is the first of the problems. So if you create your architecture of the system with the standard client-server technology, sometimes you will find the big problems on time when growing your use case or multiplying it on other regions. Secondly, in the different parts of the world, you have different questions about local producers of devices. Which automatic doors will be in China, in South America, or North America? You don't know. And to start working with different producers of smart devices, it's, in my opinion, not the best way. So what is another way? Here is some of the problems what I addressed to resolve with the Polkadot technology. The first of all, it's a global availability. So it means you can produce different type of smart devices in one region and be sure that if someone will use it in other part of the planet, its smart device will be available for your mobile application. What is, in my opinion, dangerous in time when, for example, Xiaomi tried to sell some stuff in the United States, and you know that in any day, firewall will start working better than now. Secondly, it's a cybersecurity problems. It's no security risk when you connect 100 mobile robots to the one server. The problem will be when you will start to connect thousands, 10,000s of the different smart devices to the one server. So cybersecurity risk growing with the growing your project. If you use client-server technology for your project. And last one, data privacy. Different country has different rules to settle the data, so it's very hard to find a good option to connect different countries' sensors to one data center in one country. So to address these problems, we try to use Polkadot technology, and what right now you can use for that, and what can resolve the question of global availability, cybersecurity risk in time of growing, and data privacy. The first of all, called digital twins on blockchain. So you can just put our meta information in digital twin of your smart device, and it will be available for whole life cycle of your devices without any intermediaries or any server to get like a passport of your device or some important information. Secondly, and I guess it's the most powerful thing for blockchain adoption for IoT, you can think about not to create an API, but to perform technical and economical transactions from your logistic robots for environmental outside. Because if your smart autonomous car can pay for charge, you don't need to create relations with the companies in local regions. So if you bring your sharing to some local region, you don't care about API relations with the partnership. It can pay as other drivers for the services. And the last one, your users will not require it for authentication purpose to connect to cloud, because right now it's really big question for smart devices company to find approach to connect your mobile application with your smart home solution. Mostly they use cloud to authenticate you to grant access to your smart home lamp. But with a centralized application, it can work perfectly with your own keys. Yeah, so that's it. So now we will try to show you demonstration. Vadim will help me. He's from Robonomics team who works 5 years with me. He was in Buenos Aires last year when I was in Berlin. And together we will try to make the next. I will send transaction through decentralized application. Transaction will launch this robotic arm. When it will start working, Vadim will try to control this dog with acceleration camera on the board. And if dog will not fail, the lamp will show the green color. If its acceleration camera will find the critical angles, that means that it's foul and lamp will be red. So different type of robots connected to the same power chain will try to work together to show some entertainment for you. We will try to make it. We have two problems. First, the bottom leg is broken, so it's a crazy dog right now, and it's very hard to control. Secondly, it's a dramatical, the same what happens with the Titanic. case last month, this joystick with the Bluetooth connection worked not perfectly. So we have two issues. What we will try to make, and if not, we'll use this one to replace one part of the system. But anyway, let's try. Yeah. So here is our dexterized application. Now you can see I will send transaction from my account. I hope asynchronous baking will happen at August and September, and time will be decreasing 2 times. So it will be not so many time to wait before it will start. Yeah. Let's wait. Transaction. Yeah. Now it's flag to start. Spot. Yeah, and the first attempt was a fail, so we will wait the transaction with a fail. And what is interesting in this case? Have a look. Vadim controlling the body of this dog, but acceleration camera is independent engine, which is like oracle for this system, which can understand it's fail or not. So Robodog can cheat with that. It's an independent agent. So we have a first agent here, body of the dog, the acceleration camera, and lamp. It's what I code, and everyone in robotics code a multi-agent system times. Yeah. Yeah, it's happened. Let's try another one. For example, we can make it with extrinsic, for example. Have a look. Subscription. No? Yeah. Yeah. Cool. Choose the subscription. After take a launch. Robot arm. Yeah, we're on the finish line. One more attempt. Now it's worked. Vadim. And second one is failed. We'll wait the transaction. We don't have enough time to show you, but what is more interesting? All of this stuff with some entertainment interaction will be available from the September for all of you. So you can create address on Robonomics parachain, connect to our online available laboratory where we have different cameras which will show you the real picture. You can try your skills to make a slam, make a obstacle avoidance with the same, or not the same, but another one, better working robot, and try your skills with some robotic stuff. Yeah, finally it's made. So, as I said, we don't have any time. Here is just a little bit about our laboratory. and we can still continue working with Sergei smart home concept, come to our website, find more information, ask any question about in Discord, and connect to our virtual laboratory, which we think will be very good example how we can create a community of robotics engineers who will be interested in Web3.
Wonderful. Thank you so much. We really appreciate it. That was incredible. Let's give another round of applause.